Hello, my name is Denis Mushinov. I'm staff front engineer on the AI framework team. And in this team, we believe in accelerating the new ideas to enable more teams and individuals to come up with new creative AI features quicker and easier. In this third video of the Easy AI Experimentation series, we are going to continue working with our AI experimentation project. I will remember where we left off. So in the previous video, we were running this setup storage step from our Python experimentation for the is this known feature. we are still evaluating the idea in order to figure out whether it's worth implementing or not. We just in the second and third video, we take it a step further from the first video where we just played with it in the context of Google and Anthropic consoles. Here we do things a bit more advanced with somewhat small bits of coding. However, we still do not pull in the complete GitLab AI machinery, and this it gives us a lot of freedom in order to fine-tune our feature. Now, let's just run this first step that we were doing during the last video, and we will talk about what it does. So run all cells. So I will just let all the cells run here. And in the meantime, what this step did last week, or last session, excuse me. So it allowed us to set up the modules, separate modules for text completion, text generation, and embeddings. We pulled data from our GitLab API, converted into the documents, vectorized those documents, and put them into the vector storage, which is located locally on our hard drive. We do not use any real vector database. We just dump it into the file, into the JSON file on our file on our hard drive for now, because we are just experimenting. We do not want to go all the way to involving different tooling. So we left this off at the moment when we made sure that the data has been fetched, stored, and we can query it. So let's take a look. All of these steps, all the cells in this step were run, and when we ask what issues with DuoChat are you aware of, again we still get two responses. I think for the sake of this experimentation, remember I told you that you can run these steps in Python environment or Node environment. So let's make sure that it still works in the Node environment. As you can see, this is the Dano kernel, and it's about exactly the same steps. So let's run all of the cells here, and make sure that we get some response at the end here, which should probably be more or less similar to what we got in Python. So the first one is DuoChat does not currently support speech to text. And then second, when the DuoChat window is already open and focused on another part of the UI, using keyboard shortcuts to open or focus. Okay, yeah, so lack of speech to text. Thank you, LLM. It just summarized the things to me. So lack of speech to text support, keyboard shortcuts not properly working. And this one actually finds somewhat different. That's interesting. Feature request, speech to text is here, but then there is something about the visual contrast. This is interesting. They both get some information, but this is really, really interesting. So actually add speech to text is pretty new. To DuoChat, it's the first one in our API response. Well, okay. Still, they do provide information which is really DuoChat oriented. Let's close the Node environment for now and get back to the Python to the Python one. So we created our vector storage. We can query it. Still, we're not getting the really nice results, and we have to have much more control over how we present this. So for that, we have this second notebook, which is called Tool. Why is it called Tool? Because in the AI world, in the AI terms, tool is something which does one particular job. Then you can assemble the tools into different agents, and then that's where prompt engineering becomes really exciting, where you can write prompt in the agent to pick different tools based on the prompt from the user. In order to illustrate this here, let's assume in this particular case, we fetch issues from VS Code. But in order to make this more comprehensive, we have to fetch issues from the GitLab, from the main project as well. And each of these can be the separate tool. The one dealing with issues for VS Code and one dealing with issues for GitLab. And then we would create an agent which would, based on the question, based on the prompt, be able to pick either find the issues in the GitLab vector storage or in the VS Code vector storage or in both of this. So, but we won't get that deep in these experiments. We are going to work with just one tool, which, again, those who like hype among us, technically this storage setup, so setting up the vector storage and then running this tool with prompt engineering is what is actually RAG, retrieval augmented generation. So we retrieve information from the vector storage, we augment the prompt, and then we generate response based on this contextualized situation from the LLM. But in order to retrieve the information, we have to put information into that vector storage. So all we do during second and third videos is technically RAG. So with hype out of the way, let's get to our tool. What does this tool do? It, again, does exactly the same thing as the it's actually the Node one. Let's go to the Python one. Python and tool. So it does exactly the same thing as the storage. We just make sure that all of the dependencies are here. Then we set up the modals. In this case, since we really need to generate correct and proper text and make sure that the modal understands our instruction. If you take a look here, we were using Claude 2.1 modal for text generation because we didn't really care about this. This text was queried only to make sure that LLM has access to our vector storage. In this case, we are technically getting to the final response, and here we have to benefit from the best text generation capabilities of the models. That's why we upgraded to Claude 3 Sonnet. Again, you see how simple it becomes to switch different models for different tasks in this particular project, AI experimentation. So, but this is technically exactly the same as we do here, just with different models. So we can collapse this step 1.1, or actually let's just run it probably, right? So we do run it. We make sure that everything is installed. Bum, 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 bum. Again, it checks everything. Already satisfied. Yeah, everything should be set up. So it's done. Now we are on the next cell. We run it. We set everything up, and hopefully we will be able. Yes. So we set the Claude 3 Sonnet as the text generation model and text embedding Gecko as the embedding model. Again, this is very important. The model you're using, the embedding model you're using for retrieval part, should be exactly the same model you used to create those embeddings. So the model you use for creating the embeddings, the vector storage, should be exactly the same model in order to speak the same language and understand what to expect there. So this is technically exactly the same as we had. initialize an index from the local data storage. This is similar to what we had previously, but here we do not need to fetch data. We do not need to do anything else. We just connect to our local storage folder, and that's what our index is. If you remember in the setup storage, we had to set up the data store, just pointing this to this local storage, and then we were putting items, our documents that we fetched from GitLab API, we're putting there, and then we were initializing the index. We were indexing the documents, and then we were creating the index to query. For the retrieval part, we don't need to do a lot of these things. For the let me just collapse this. For the retrieval part, we just connect to the already existing storage, which is on our hard drive now, and use this as the index. That's pretty simple. Let's run this this cell as well. Yep, it ran smoothly. Let's collapse. And now we are getting to the really exciting part. This is where we build our custom prompt, which is the meat of our RAG technically. But before we dive into this, note how simple the tool is. So again, if we collapse all the repeatable steps in this part and leave only those that you need to work with when setting up the storage, again, just to remind about this, you have to fetch data from the API or do something else, generate somehow data, somehow your feature might require, then convert it into the Llama index documents. Again, this step is more like specific to this particular implementation, which is driven by Llama index. And then you're ready to query. But in this step, you technically don't even need to query. The real querying happens in the tool, and these two steps can stay the same for whatever you do technically, if you don't want to play with the models and change the models. But you can leave them as the defaults. When you clone this project, you copy these notebooks into your experiment, and you just keep this collapsed, and then this is what you are going to work with, the prompt and then the query. We will go a bit backwards here, and we will check what is the prompt. So the prompt is, as you remember, we're working with the evaluation of is this known feature. So is this known that when working with a file, pressing the keystroke does not move the cursor into do chat? Easy enough. It's technically the same question essentially as we used in the video number 1 when we were querying the text generation models of Google and Anthropic. Just technically the same thing. We know that we are in the context of VS Code extension issues, so we do not specify that. We just ask the same question essentially here. And now let's get to the custom prompt thing. And this is where things become exciting. And in order to write good prompts for LLMs, you have to realize that LLMs, even though they are surrounded by this umbrella term artificial intelligence, there is very little intelligence per se. What it means is that if you do not instruct your LLM to do things the way you want to do, if you do not explain as to a little child, a little kid, how to do things, how to distinguish things, you are prone to mistakes and deviations in terms of, in this situation, it will be this answer. In this situation, it will be this answer. So it will be very non-deterministic approach. So you have to be very clear in the way you give the instructions to LLM in your prompt. And the prompt here, technically for this experiment, it's pretty simple. So what we do here is we instruct the LLM right away that there will be the context here. The context information is below. Here we separate the context, we mark it with capitalized letters, context, and then this is where our context string comes, which it will be injected here using Llama index internals But what this technically means is our embedding model will go to our vector when our text generation model, in this case Sonnet 3, will read our prompt. It will instruct the embedding model to reach out to our vector storage and find the most relevant entries. As you remember, they are stored in the numerical format. So fetch the most relevant chunks of information. Then it will assemble that information into some sensible thing, and that's what will be returned as context string. So it's the combination of embedding model work, retrieving the information. Remember, RAG, retrieving the information from the vector storage and allowing the text generation model to make some sense out of this. And then this is the context. This is what we send as context. Now, we also specify the answer format. We want this, in order for people to appreciate this tool, we want the answers to be pretty short and very informative. So we explicitly specify the format. It appears that the following issues might be related, and then just the list of issues where we have title and issue web URL, and we right away assume a markdown format here. And then we give the instructions. Given the context information, answer the query. If the query asks whether something is known or not, answer based on whether context already contains similar information. If there is similar information in the context, provide a list of issues with similar information strictly following the answer format. As simple as that. The only thing that is tricky here is to instruct LLM on how to tell whether an issue is similar to the prompt or not. And that is not even sophisticated here. It's pretty straightforward. So let's try to run this step of building the custom prompt. So it ran really fast because there is nothing to run here technically. And now to the fun part. Let's wait to what the LLM will come up with. And it spits out exactly the answer that I was expecting. Remember when we were playing with this in Anthropic, in Google, they were kind of adding things like mutating the response, augmenting it to the level they wanted. You could play there in order to get exactly the same precise response here. You probably could play with the temperature for the model, which the parameter which justifies the how deterministic should be the answer. So the lower the temperature, the more deterministic answer you will get. But in this particular case, it strictly follows the answer format, just like we informed it. And notice one thing. So the answer format says it appears that the following issues, so multiple, plural form, might be related. AI is intelligent enough to not use issues, even though I told it to strictly use that format. It corrects it to issue because we have only one. And then it points to exactly correct issue here. And if you click the link, we get that issue. And with this result, I think we could conclude that this is a success. We have reached exactly the point of our experiment, which shows exactly how to approach this problem without delegating a lot of magic to the consoles, as it was with Anthropic and Google. Here we know every step, and we can communicate these steps to the engineers who might implement this. We can communicate this to product manager, showing that this is how we intend this to work, and to decide whether there is a value in this. But This is a really good final experiment with AI without pulling in GitLab AI machinery. However, after this experiment is done, most probably it will end up in Google and in GitLab. Maybe even in Google, I don't know. It will end up in GitLab probably, but with different, with probably somewhat different implementation. Because if we go back here, if you're a front engineer, you can run the same thing in the JavaScript. Let's run it for the just for fun to see whether it will work out. I don't know. I don't think I ran it in Node yet. What I will do though is I will collapse all these steps. I will leave the build the custom prompt, and the prompt is more or less here the same here. It just has this query and answer. I don't remember why I added this here, but let's see how it affects actually the thing. There is one catch here. For Node implementation, there will be one more step in for building a query engine. It's not as straightforward as in Python. That's why I say that Python for this type of things is a bit simpler, and it's not that hard in this to work with in the context of Jupyter notebooks. But you will be able to investigate. If you want to work in Node environment, you will be able to investigate. It's really straightforward. Everything is documented due to the notebooks format, so everything is clear here. But what I'm interested in is actually running all the steps, all the cells, and then see how. Okay, query engine is not defined. Let's take a look. So right. Okay, I don't have OpenAI API key set up in my environment for Node. Sad. Well, if you want to try this with your personal or your private OpenAI API key, probably it will be fine. Again, to remind you where this OpenAI API key comes from, we use text embedding ADA 002 model for embeddings, both when we create the storage and when we retrieve information from the storage. Why do we do this? Why can't we use Vertex here? This is one more catch when it comes to the Node implementation. As I said, Llama Index comes with very good OpenAI support out of the box. But in order to set up other models like Anthropic, you technically need to install some things. Anthropic is fine, like the text generation models are fine. However, when it comes to the embedding models, I didn't find any easy way to add Vertex model into the Node environment of Llama Index. So maybe somebody will figure that out, and we will update this experiment. But for now, I just wanted to experiment, and so I used my personal OpenAI API key, which I didn't put here. Oh, actually, I didn't even put the Anthropic API key here, so probably I didn't put .env file at all. But with that being said, if you put all the keys, the Node implementation will also work. It is a bit more complex when it comes to the tool compared to Python. But if you want to play with Node instead of doing this in Python, you're free to do so. You can do that, and technically you are supposed to get exactly the same result as we got in the Python environment. Now, to wrap this up, during these two last videos, we were using the AI experimentation package, which implements one AI experiment, which is this known? This is the experiment that we were trying to evaluate in the very first video using the consoles from Google and Anthropic, and then in the video 2 and video 3, we've got to a bit more code-oriented environment, but very, very flexible, very exciting environment, in my opinion, where we can write instructions in Node, we can write instructions in Python, and we built we built the experiment as RAG, we were able to create fetch the information from our servers, from our API at GitLab, put those into the vector storage, then go to the tool and retrieve that information using the embedding module, augment the prompt with all those, with all these things. So this is technically the prompt, and this part is what is the augmentation as it stands in RAG, where we augment this simple prompt into something much more complex. We supply the context, we give the instructions, and then we generate the response to the user. So RAG, retrieve, augment, and generate. We generate the response based on all those two previous things. So again, I would like to thank you for watching these videos. If you didn't see the first one or the second one, please make sure you do that. And please do reach out to me or to AI Framework group if you have any questions about how to bootstrap your AI experimentation in an easy and simple way. Thank you very much.